Okay, so this is the given question that a wave is propagating on a long straight string along its length taken as the positive x-axis. The wave equation is given as where y naught equals to this, t lambda is given. You need to find the velocity, you have to find the function giving the displacement of the particle at x equals to 0. You need to find the function g of x giving the shape of the string, plot the shape and into at t equals to 0 and plot the shape at t equals to 5. So let's get started. So what are they saying is there's a wave which is going in the positive x-axis. Okay, so whenever it comes positive x-axis, f equals to, you need to take it as t minus x by v. Okay, if it is if it is the wave is traveling in the negative x-axis, you need to take it as plus, but if it is positive then you take it as minus x-axis, minus x by v. Okay, this is the thing you need to remember. So in the question the given function was y equals to y naught e power minus t by t minus x by lambda whole square. Okay, so they gave you the value of y naught equals to 4 millimeters. They gave you the value of t equals to 1.0 seconds, and they gave you the value of lambda equals to 4 centimeters. Okay, now you need to find velocity. The first thing you have to find the velocity. Then you need to find the function f of t. Define the function f of t giving the displacement of particle at x equals to 0. Then the next thing was find the function g of x of the particle at t equals to 0. And then you need to plot the shape like g of x, okay, at t equals to 0, and plot the shape of g of x again at t equals to 5. Wherever they give you g of x, it's related with shape always, okay, and t will be equals to 0. Remember this thing, t will be constant, whereas in f of t, x will be 0, okay, displacement will be 0. So let's see. So if you see the equation just now I kept was y equals to f of t minus x by v, right? So if you just compare this with this, so you have y equals to your y naught e power f of t. What is t? You can see this one is t, this is minus x. What's v? V is looking like lambda, right? So before that we will just take out this t common, okay, this t square, this is t square. So let us take out the t common, we'll get as 1 by t square by t minus x by lambda by t whole square, right? Yeah, so it will be like this. So now if you compare, this will be t minus x, what is in place of v? It is lambda by t. So it's lambda by t. Now if it is lambda by t, now what is the value of t given? It is capital T. Okay, what's the value of t and lambda? It is given as lambda is nothing but 4. So it's 4 by t is nothing but 1.0, that nothing but 4. So velocity is nothing but 4 meter per second. You got the answer for velocity. This is what you did is you just took out t common from here because it was t square. You took out 1 minus t, sorry, 1 by t square common. T is as it is, and then by minus x by lambda by t whole square. This is capital T. Okay, yeah. So our next question was like B was, you need to find the function f of t. You need to find the function f of t giving the displacement of the particle at x equals to 0. So put x equals to 0, you get this. So what you get, y equals to y naught e power minus, this is t by t will remain same. This x equals to 0 means this whole will become 0, so t by t whole square. Is that clear? Now the next question was, you need to find the putting t equals to 0 in the given equation. Okay, so it was that find the function g of x when t equals to 0. So you need to put again the same thing here. You need to keep the t equals to 0. So you get y naught equals to, y equals to y naught e power. If you keep t equals to 0, this whole term will become 0, and this will be like x by v. This minus will become plus because square is there, so x by v whole square. So you get minus x by v whole square, like this. Clear? Oh, sorry, the question is like lambda here. That was lambda, so here it will be lambda. Not v, it's lambda. Okay, just concentrate. The next one was you need to plot the shape of g of x. Plot the shape of g of x of string at t equals to 0. So you will get something like this. At t equals to 0 means x equals to 0. So here it will be like this. Just remove this, you get something like this. Your answer, x equals to 0. If it is t equals to 0, then x also equals to 0. Remember that. Then they were like g of x equal when t equals to 5. G of x when t equals to 5. Okay. So we had this like f equals to, f of, so it was like f of t minus x by v, right? We had velocity, what we got 4 velocity, so this will become 0. So suppose this is 0, so what is t? This now is we put at 5, so 5 minus x by 4, and this will be like 4 5s are 20, so 0 equals to 20 minus x, so x equals nothing but 20. So you can just keep it x like this. So here somewhere, if it x equals to 0 here, then at somewhere here it will be x equals to 20. Here you will get the wave. Is that clear? So x equals to 20 centimeters.